Hey guys, and welcome to my next video, and this one today is on simple machines. So we're going to talk about how do machines make work easier. One good example of this, you guys, really cool show on Science Channel. Alright, it's called How It's Made. Alright, so How It's Made has a lot of these machinery that's designed to actually make objects without much effort, and that's the whole point. So machines make work easier, have less people working on something, and they allow things to be manufactured at much rapid pace. So watching How It's Made will show a perfect example of that. It's really cool. I really recommend the show. It's just amusing to watch sometimes. Okay, so what is a machine? It's a device that allows you to do work more easily, allows you to exert more force with less effort. All right, that's the goal. So a wheelbarrow, compared to deadlifting soil as an example. So this guy is pushing it with the wheelbarrow, and you know it's much easier to roll it than it is to deadlift it, which you're fighting gravity directly. You are fighting gravity a little bit because you got to hold up the wheelbarrow, but still, the wheel allows for less friction, less resistance with gravity. All right, so a wheelbarrow to move dirt is an example of definitely a machine to make work easier. All right, so how does a machine help you do work? Well, it can change the amount of force you exert. Okay, so in some cases, you want a little more force applied to your object. So an example here, they're using a lever to move a boulder. The fulcrum here in the middle allows you to change the direction also. So we can do that also. We can change the direction you exert the force. You can also change the distance you exert the force on the object. So instead of just pushing in one little area on this rock, this lever can go underneath the rock and push both up and forward at the same time, which your body has a hard time doing. So the lever will actually give you extra leverage over the object and allow you to move it. Okay, now there are different forces involved when you're moving an object. So there's input force. That's the force you exert on the object. All right, so in the case of what's called the hand truck here, which is used to carry heavy objects like paper. I don't know if you guys ever carried boxes of paper. They're actually much heavier than you think. But either way, input force is what you put in. Output force is what the machine exerts on the object. So in the case of these boxes of paper, the output force would be resisting gravity. So you want to overcome gravity the best you can as you're using that machine. And we use something called mechanical advantage. This basically is a calculation of how much a machine increases your ability to do work. So we take the output force divided by the input force. And obviously the ideal thing is to have more output and less input from you. If they're equal, then there's almost no point in using that machine. Obviously, if you're not getting the output, then the machine's not working. And then the third thing is if you are actually getting more output than you're inputting, then that's a good machine. So you got to think of it that way, right? And we calculate that to figure out the efficiency of our machine. All right, so what are the different simple machines? Okay, the first one is called an incline plane. The reason why it's an incline plane, one side is higher than the other. So it's a flat surface, one end higher than the other. So a moving truck ramp is an example of an incline plane, a wheelchair ramp, because you're resisting gravity by allowing objects to roll up this incline. All right, so it definitely allows us to make work easier, allows objects to roll easier uphill rather than just straight up overcoming gravity. Next is a wedge. So wedges are a double-sided incline plane, so they come to a point like this. The effort is applied by driving the wedge into something. So an example could be like an axe, which is used to split wood, a knife, obviously to cut objects, nails, right? They're actually splitting apart the wood material as they go in. Chisels, all right, when you're trying to scrape off pieces of wood, all right? So those are all examples of wedges. So anything that cuts pretty much or drives into something. Okay, lever, which we already saw. This is a rigid stiff bar that can turn around a point called a fulcrum. So the fulcrum obviously is best situated at some distance between the object and you. So the fulcrum you want pretty close to the object you're moving. And you want to force or push down the object, the lever on the opposite direction you want the object to move. All right, so scissors is a good example of this. Crowbars, all right, when you're trying to pull out nails from the wall. A seesaw, all right, one side goes up, the other side goes down. Okay, so that's an example of a lever. Okay, screws. These are incline planes wrapped around a wedge or cylinder. So wood screws, a good example of this. Bolts, car jacks that are actually the spiral ones, not the pump jack. But either way, they all have these spirals that are hard to actually back out. All right, so that's the beauty of those. Okay, so anything with like a spiral type motion, which again will resist motion in the opposite direction, which is nice. That's why screws now are used to fasten things to the wall more so than nails. Nails can pop over time. Screws tend to hold a lot harder because they actually have to be spiraled to come out. Okay, wheel and axle is next. Just note the spelling of axle. I always spell that wrong. It's like one of those words. A-X-L-E. A-X-E-L is the actual name axle. And sometimes that's the reason why I mix up the spelling of that. So a large wheel or a small wheel or axle in the middle. Basically the whole point of this sometimes is to spiral an object to get force on the other end. All right, so a good example of steering wheel in a car to turn your wheels. All right, it turns that steering rack inside your by your motor, which then turns your wheels left or right. Your bikes, the handlebars, okay, same thing. Doorknobs, you turn the doorknob, it rotates and then rotates the inside, which then pulls your little pin out from side and then opens the door. Bicycle handlebars, as I mentioned, and screwdrivers. The other end of the screwdriver is a smaller shaft, which then turns from the bigger shaft on the other side. So that's a wheel and axle. Okay, pulley. This consists of a rope and one or more wheels. Weight is attached at one end of the rope or one of the other wheels. And what ends up happening is the more wheels, the less work. So a single pulley is pretty good, right? Because you're resisting a little bit of pulling. So instead of deadlifting an object, if you pull downward with the wheel, it actually resists gravity much easier. It allows you to hold the object more effectively. And you could do a pulley like this also, where you pull upward rather than downward. And then the other situation, you could have a double pulley. These are even stronger. So if you suspend a wheel up here, connect a second wheel down here on the load, and then go back to the original, you can actually pull up the object much easier. And they do this again with like car engines, little hoists that you actually use. They're definitely more effective at lifting really heavy objects. Okay, so how do they all work? So most of these simple machines allow you to exert a force over a longer distance. All right, that's the goal. So incline planes, wedges, screws all do that. allow you to exert a force over a longer distance. Okay, a lever will not only change the amount of force you exert on the object, but change the direction fully. All right, so because you push down this way, the object goes the other way. All right, a wheel and axle increase the amount of force by exerting more force over a longer distance. So once again, and pulleys change direction and the amount of force exerted. Okay, so, and again, the more wheels on the pulley, the more effective it is. All right, so here's an example, a bike. So all the parts, so the chain is the pulley. All right, so you know the pulley that goes all the way around. Handlebars are a wheel and axle. The sprocket wheel, which is right here by your pedal, that's a wheel and axle also. A pedal is a lever, right, because you're pushing down. Handbrakes are also a lever, right, that pulls the metal string or metal cord that basically pulls your brake on the back wheel or front wheel, depending on which one you pull. All right, and that's pretty much the parts of the bike. And again, those are all the simple machines. They come together to make what's called a complex machine. So bike technically is not a simple machine itself, it's a complex machine because it has many simple machines linked together. All right, and here's some more examples. So again, incline plane, wedge, right, like an axe. A screw is a obviously like a screw you screw into the wall. A pulley, a wheel and axle, and of course a lever. All right, and that's it for simple machines. Thank you guys for tuning in. And another thing you can look up to, which we're going to do in class, is Rube Goldberg experiments. All right, we can actually design our own, which that's what we'll do in class. All right, thank you guys for tuning in. I'll see you next time.